Today I'm gonna talk about a case study too. It's about telemetry and data acquisition. First of all, I'm one of my Kamel, and then this is our team member. So first of all, how is the structure of the data acquisition? The process is the data acquisition is the process of sampling signal that measure real-world physical condition and converting the result sample into digital value, such as the 0 and 1 value, can be manipulated into by computer. So the acquisition data system is typically convert analog waveform into a digital value for easy process. So you see the transducer or the sensor will convert the electrical signal from the tag device, and then the tag device will send it to the computer. So about structure of telemetry system. Telemetry system is a system designed to collect data from remote or far location, transmit into a central location, and display the process for monitoring, analysis, or making a decision. The structure of telemetry system generally includes the following component: the physical system, transducer, sensor, signaling, the converter, and the computer. So this is the main key components. The sensor will detect any signal which will convert into electrical signal by the data acquisition unit, and then it will transmit into a system, and the computer will receive, and usually the computer will do the processing and store the data. Also, the user interface and monitoring is for analysis and monitoring. Control and feedback is just for extra commodity.
Hello, I'm Imran. To continue, there are two types of telemetry amplitude. First, voltage telemetry. Voltage signal can vary in amplitude over a set range to from 0 to 5 voltan, making them sensitive to signal degradation over long distance due to resistance and electromagnetic interference. They are typically best for short distance or noise-free environment. Second is current telemetry. Current signals maintain a consistent amplitude over distance and are less affected by interference. This makes current telemetry more reliable for long distance or electrically noisy environment as the signal strength remains stable. Up next is frequency of telemetry. Voltage to frequency converters takes an input voltage signal and converts it to a proportional frequency. For example, from 0 to 10 voltan input after converted to a frequency range of from 0 to 10 kHz. This frequency signal can then be transmitted over long distance with less interference to noise and signal degradation compared to direct voltage telemetry. Frequency to voltage converters is the receiving end. The converter is used to decode the frequency signal back into a professional voltage. For example, from 0 to 10 kHz signal received is converted back to a from 0 to 10 voltan output. This allows the original voltage signal to be rebuilt for further processing or display.
My name is Muhammad Jumadil, and now I'm going to continue on multiplexing. Two types of multiplexing: frequency division and time division. Frequency division multiplexing FDM technique used to combine multiply signal into a transmission channel in FTM. The available bandwidth of the channel is divided into distinct frequency bands, each of which is used to carry on signal. Each signal is modulated onto different carrier frequency, allowing multiple signals to be transmitted simultaneously over the same medium without interference. How FDM works. Signal allocation of each signal transmitted is modulated onto a specific carrier frequency. Bandwidth division by the total available bandwidth of the communication channel is divided into smaller frequency bands, combining signals into a signal composite signal for transmission over the shared medium via by a coaxial cable, optical fiber, or radio spectrum. Transmission: the composite signal is sent through the channel to the receiver, demultiplexing at the receiver filters. Spread: the composite signal into the individual sub-channel, then demultiplied to retrieve the original signal. The second, time division multiplexing TDM technique multiply signals are transmitted into a signal channel by allocating distinct time slots for each signal. Each signal is transmitted in its assigned time slot on after the other at a very fast rate, giving the illusion of simultaneous transmission. How TDM works. Signal sampling of each source at regular intervals, often using the Nyquist theorem to ensure accurate reproduction of the original signal. Time slot allocation is communication channel that divides signal in each time slot and assigns signal in unique slot in a repeating sequence, multiplexing the signal interleaved in time, forming a composite signal that alternates between data from the different sources. Transmission of composite signal is transmitted over the shared medium to the receiver. Demultiplexing by receiver, the composite signal is divided back to individual signal by separating data based on the time slot. That's all from me. Thank you.